This is not supposed to happen in Texas. On the morning of July 23, 2026, at 5:21 in the morning, the ground shook hard across a stretch of flat ranch and cattle land in the Texas Panhandle near the Oklahoma border. A magnitude 5.0 earthquake centered approximately 24 miles south-southeast of Spearman in Roberts County, one of the least populated counties in the entire state, with a total population of just 827 people. The shaking reached Amarillo, Oklahoma City, and Tulsa. Residents in southwestern Kansas and the northern edge of the Dallas-Fort Worth area reported feeling it. Some people 250 miles from the epicenter felt tremors from a source they could not see and could not explain. And the strangest part of this story has nothing to do with the shaking itself. It has to do with a buried scar 500 million years old that shares its exact geological blueprint with one of the most violent earthquake sequences in American history, located hundreds of miles away. Because what is sitting underneath the Texas Panhandle right now has scientists genuinely uncertain about what just happened there. Roberts County Judge Mitchell Locke, who serves as the county's emergency management coordinator, described being woken up by his cat before he felt the shaking himself. He said it was noticeable but not violent, nothing too extreme. That description captures the physical experience accurately, but it does not capture what the numbers behind that shaking actually mean for a region where earthquakes of this size almost never happen. According to the National Weather Service office in Amarillo, nearly 91% of all known regional earthquakes since 1907 have been below magnitude 5.0. The epicenter was located in northwestern Roberts County at a depth of approximately 5.7 kilometers. That shallow depth is precisely why the shaking carried as far as it did. When a rupture occurs deep underground, the surrounding rock absorbs much of the seismic energy before it reaches the surface. At 5.7 kilometers, there's almost no cushioning. The energy hits the surface close to full strength and radiates outward across the flat, hard soil of the Panhandle with very little to slow it down. Like and subscribe. Because the disagreement between news outlets covering this event is itself one of the most revealing details in the entire story. Within hours of the earthquake, a contradiction emerged in the coverage that nobody seemed to fully resolve. Some outlets reported this as the strongest earthquake ever recorded in the Texas Panhandle. Others said it was the strongest in more than a century. Local media reported it was only the fourth earthquake of magnitude 4.0, or greater, documented in the region since 1900. All three descriptions can be simultaneously true, and understanding why tells you something important about the limits of historical seismic data. An older National Weather Service historical compilation estimates that earthquakes near Panhandle in 1925 and near Dalhart in 1948 had magnitudes of 5.4 and 5.2 respectively. But those earlier events were never measured by a seismograph. No instruments existed in that remote stretch of land at the time. Scientists of that era reconstructed the earthquake sizes after the fact by mapping where people reported feeling the shaking and where damage appeared, working from old letters, newspaper accounts, and descriptions of cracked plaster on living room walls. That reconstruction might be reasonably accurate. But it is fundamentally a number built from human memory and observation rather than instrument data. Comparing it directly against a 2026 earthquake captured in real time by modern seismic networks is like comparing a hand-drawn sketch to a high-resolution photograph, and then arguing about which one is more precise. When outlets say July 23rd was the strongest earthquake ever recorded in the Panhandle, they almost certainly mean the strongest ever captured by an actual instrument, not necessarily the largest event to physically occur there across the region's full geological history. That distinction matters because it reveals how blurry the actual seismic record for this region truly is. And a blurry record makes it significantly harder to assess what the baseline actually looks like, which in turn makes it harder to determine whether what just happened is an unusual outlier or simply the most recent data point in a pattern that instruments have been too sparse to fully document. Like and subscribe, because the geological structure sitting underneath the Panhandle is where this story becomes genuinely extraordinary. There's a fault system buried beneath this region that is not new. It is not a crack that formed recently from drilling or industrial pressure. Geologists have traced it back to something called the Amarillo-Wichita Uplift, the buried remains of an ancient rift, a place where the North American continent itself once began to tear apart and simply stopped before the process was complete. This failed rift dates to the early Cambrian period, roughly 500 million years ago, long before dinosaurs, long before anything with a backbone had crawled onto dry land. For most of that time, it has been sitting silently beneath the wheat fields and cattle ranches of the Panhandle, occasionally producing small tremors, occasionally producing something larger, and then going quiet again for decades. In the last 5 years, Texas has experienced 7 earthquakes that measured at magnitude 5.0 or higher. And the Spearman earthquake is tied for the 6th largest in Texas history. Most of those larger events have been concentrated in West Texas, where the connection to oil and gas operations has been extensively studied and in many cases confirmed. The Panhandle is a different story. Scientists are now investigating 4 separate explanations for what caused the July 23rd earthquake, and they have not ruled out a single one of them. The first, and currently leading natural explanation, is that accumulated tectonic stress found the weakest available point in the crust and released there. Tectonic plates move slowly but continuously. That movement builds stress throughout the surrounding rock over years, decades, and centuries. Ancient fault structures, failed rifts like the one beneath the Panhandle, are weaker than the surrounding crust and therefore more likely to slip when regional stress reaches a critical threshold. Under this explanation, no human activity is required whatsoever. It is simply geology doing what geology has always done, on a timescale that makes human history look like a brief flicker. The second explanation involves historical oil production, an angle almost no outlet covering this event has mentioned, despite it being genuinely relevant. Several older Panhandle earthquakes, including events recorded in 1936, 1966, 1974, and 1980, occurred directly above major petroleum fields that were actively being drilled at those times. Researchers who studied those events suggested the drilling may have triggered them. But the equipment available in those decades could not accurately determine the precise depth or location of those earthquakes, which means that connection remains scientifically uncertain rather than confirmed. The third explanation is the one most people immediately assume when they hear Texas. And earthquake in the same sentence, modern wastewater injection tied to oil and gas operations. A study published in 2022 in the American Association of Petroleum Geologists Bulletin found a sustained rise in earthquakes measuring 2.5 or higher across the Panhandle region. That research identified patterns consistent with injection-triggered seismicity in smaller routine events accumulated over decades. But officials responding to July 23rd's earthquake have been notably careful about extending that conclusion to this specific event. It is unclear what caused the earthquake in the Panhandle, and there are some minor fault lines in the Texas Panhandle that could cause weak to moderate earthquakes even without any industrial trigger. A magnitude 5.0 is substantially larger than typical injection triggered events, and unlike the extensively studied cases in West Texas's Permian Basin, this particular earthquake does not yet have the supporting data needed to make that connection with confidence. Like and subscribe, because the fourth explanation is the one that researchers are being most honest about, and it is also the most important one to understand. The fourth explanation is that nobody fully knows. And in this specific case, that is not a failure of science. It is science working exactly as it should. Determining the true cause of an earthquake like this requires detailed data collection, careful depth analysis, comparison of the rupture location against known injection sites, and modeling of the regional stress patterns, work that takes weeks or months, not hours. Within hours of the earthquake, scientists were already saying publicly that they could not yet determine a cause with confidence. That honesty deserves more credit than it typically receives in breaking news coverage. Now here is the detail that geologists find most significant about the structure sitting beneath the Panhandle. The Amarillo-Wichita uplift shares a strikingly similar structural profile with something called the Reelfoot Rift, another ancient failed rift buried deep underground in a completely different part of the country. The Reelfoot Rift sits directly beneath the New Madrid seismic zone, where the borders of Missouri, Arkansas, and Tennessee meet. That is the zone responsible for the New Madrid earthquake sequence of 1811 and 1812, a series of massive events so powerful that accounts from the era describe the Mississippi River appearing to briefly reverse its flow direction. Church bells rang in cities on the eastern seaboard. The landscape was permanently reshaped across hundreds of square miles. To be completely clear about what geologists are and are not saying here, no scientist is suggesting the Texas Panhandle is due for anything approaching that scale. Nobody is predicting a catastrophic rupture beneath the wheat fields of Roberts County. What the structural comparison highlights is narrower and scientifically more precise than any doomsday scenario. Both regions contain the same fundamental geological ingredient, an ancient failed rift buried deep beneath the surface, significantly weaker and more fracture-prone than the surrounding crust, silent for enormous stretches of geological time, and then occasionally reactivated when regional stress conditions are right. The recipe is the same in both locations. The scale of what that recipe produces depends on a complex set of variables that scientists are still working to fully understand. The USGS issued its standard probabilistic forecast within hours of the earthquake, placing the odds of another event of similar or greater size in the following days at approximately 2%. Small, but not zero. The agency issued a green alert for shaking-related fatalities and economic losses, with about 103,000 people estimated to have felt light shaking and 640,000 feeling weak shaking. The low damage assessment reflects primarily the sparse population of the area. Roberts County has fewer than 900 residents, and the surrounding Panhandle counties are similarly rural. A magnitude 5.0 in a densely populated urban area would produce a very different damage picture. One area of concern identified locally is the potential impact on oil and gas infrastructure in the region. Statistically, the Panhandle has now recorded approximately 4 earthquakes at or above this magnitude threshold in roughly a century. A historical rate of one event every 25 to 30 years at this size pushed the threshold to magnitude 5.5, and the estimated recurrence interval stretches to 50 to 100 years. At magnitude 6.0, scientists estimate a roughly once per 3 centuries occurrence for this specific region. July 23rd's earthquake does not look like an anomaly against that statistical backdrop. It looks like a clock striking the hour it was always going to strike eventually, on a schedule that geology sets and that no current scientific method can predict with precision. What happened in the Texas Panhandle on July 23, 2026 was not impossible. It was not unprecedented in the full geological sense. It was a half-billion-year-old fault structure responding to accumulated stress in the way that ancient fault structures occasionally do, briefly, sharply, and with enough force to wake up a county judge's cat and send tremors across 3 states before falling silent again. The ground has already stopped shaking. The investigation into exactly why it shook has barely begun. That buried scar in the crust was sitting there long before Texas existed as a state. It will still be there long after the investigation concludes. There is also a second, smaller earthquake from the same day that briefly generated confusion online and deserves a clear explanation. A separate tremor measuring approximately magnitude 3.9 struck a different part of central Texas later the same morning, hundreds of miles south of the Panhandle event. Some people online initially assumed the two were connected, perhaps aftershocks of the same rupture. They were not. Texas is a geographically enormous state with multiple distinct zones of seismic activity, some ancient and largely natural in origin, others more directly connected to the state's extensive oil and gas industry. 2 unrelated earthquakes striking different regions of the same large state on the same day is a coincidence of timing, not evidence of a connected geological event. Treating them as related would be the equivalent of assuming that a car accident in Dallas and a car accident in El Paso on the same afternoon must somehow have a common cause. Understanding how scientists distinguish between naturally triggered and industrially triggered earthquakes is worth explaining clearly. Researchers examine the precise depth of the earthquake because injection-triggered events tend to cluster at depths matching the depth of nearby wastewater disposal wells. They study the location relative to active injection sites and the timeline of whether seismic activity increased noticeably after injection operations in the area ramped up. They compare the specific fault that ruptured against regional stress patterns already mapped by geologists. When enough of those factors align, a case for an industrial trigger becomes supportable. When they do not align cleanly, as appears to be the case with the Panhandle earthquake so far, the scientific standard requires withholding judgment until the data is sufficient. That process takes weeks, not hours. The investigation is ongoing, and the cause has not been definitively established. The Texas Panhandle will almost certainly experience another earthquake someday. The geological structure that produced July 23rd's event is not going anywhere. Depending on how much stress was released and how much remains locked in the surrounding rock, the region could see aftershocks, additional smaller events in the coming years, or another long period of quiet before the next significant rupture. Geology does not operate on human schedules. The Panhandle has now reminded a generation of Texans that even the quietest stretch of flat ranch land can have something ancient and restless buried beneath it.